Okay, good morning. Last time we discussed Laplace transform. Today we are going to discuss inverse Laplace transform. The reason is because in transform analysis, usually, for example, the questions are in time domain. It's not easy to solve. Then we are going to convert the time domain into Laplace domain. Then we solve the problem in Laplace domain. Then at the last step, we still need to use inverse Laplace transform to convert the result back into the time domain. Right? So we need to know how to do an inverse Laplace transform. Inverse Laplace transform the first method is very straightforward. Okay, we are going to use the formula to do that. Anyone still remember what's the inverse Laplace transform? That means if we know the Laplace transform of the signal, how to calculate the time domain signal. We are going to do the integration of this, multiply by e to the st. Then the integration must be with respect to s. Then from negative infinity to positive infinity. So that is the direct method. But usually we do not use this method because this sometimes is lengthy. So we have a better way to do this. The second one is by inspection. So this requires us, we need to familiar with the Laplace transform. We need to be familiar with the Laplace transform pairs. That's why I ask you to memorize most of the pairs. And also, we need to know the properties. Like multiply by exponent in the time domain, differentiation, integration, multiply by t, or the power of t. All these properties will be used in this method. The last one, the next one we are going to discuss is called the partial fraction expansion. Well, it's a partial fraction expansion method. We are going to decompose a complicated Laplace transform into several simple ones. Then for each one, we can easily find the inverse Laplace transform. Right? We start from the second one. As we said, we do not discuss the first one. The second one. We use the examples. First one is if we know xs equals 15 over s squared plus 4s plus 13, how to find the inverse Laplace transform? So what we do is, we said we use inspection, so we need to be familiar with the pairs and also the properties. So look at this. What does this remind you? What signal given the Laplace transform looks like this form? On the top there's a constant, on the bottom there's a s squared or something. So what kind of signal is this? Possibly. Cosine functions? Sine functions on the top must be sine functions. Yes, you're right. Okay, sine functions we don't have. Okay, so this looks like the xt must be sine functions. Okay, so sine functions, right? sine omega t. This gives us s squared plus omega squared. On the top there's a constant omega. Right? And now we need to compare this one. S squared, okay, that is good, plus a constant squared, okay, it looks like right? But there's a plus 4s, but we don't have this term. So we need to do something here. Right? And this technique is called a perfect square. Right? We can convert this term into this kind of term. Looks like this s cannot be exactly the s. Must be s plus some constant like this term. Right? If we have this term, then this gives us s squared plus some 2a times s. So that looks like very similar to this one. So this s may be not exactly only a simple s. It will be s plus something. Does that make sense? So we are going to convert this something into, for example, okay, I just copy on the top 15. And this one, s squared plus 4s plus something, I want to convert it is a perfect square. So s squared plus 4s plus 13. I want to make this one as a perfect square. So that will be equals s plus something squared, then plus some constant here. So now the question is, what is this? Right? It's equals 2, right? So how to determine this 2? It will be half of the coefficient of the first order of s. So 4 divided by 2 equals 2. So that must be 2 here. Right? So let's see. This one will be s squared plus 2 times s times a. So that is 4s. Alright, that's perfect here. Right? And now we need a plus 4 here. So this is 2 squared. And then the next one, what we have is 13 here. But what we have in this parenthesis is plus 4. So we still need some more. What number is here? Must be 9, right? Okay, so that's plus 9. So let's give us s squared plus 4s plus 13. So this one. Right? But the difference is this one is already a perfect square, which is s plus 2 squared. Yes?
Where the 9 comes from? The 9.
9 is because originally we have 13. But in this parenthesis square, we have only 4 here. So you need to plus additional 9 to make this equal. Okay? Does it make sense? Alright, so let's write this one. So s plus 2 squared, then plus 9. So that is the technique we need to know how to do. Right? I believe this part of fraction expansion we already know this before, right? Make us a perfect square. Now compare with this one, s squared. This one is s plus 2 squared. How to deal with this one? We need to recall any properties. Instead of s, this is s plus 2. So what does that mean?
That would be your e.
Okay, e to the plus 2, so negative 18. Okay, so that is, we just assume this is s, right? Then later time we just multiply e to negative 18. So that's not a big deal. So this one must be omega squared. So we can see this omega will be 3 squared. That's nothing, we just put on the top, there must be omega, right? So it must be 3. But this is 15. So we can write 15 as 5 times 3. Make this one omega, then this is 5. Then definitely we can move this 5 to the front. So that is just trivial. To make this one like omega over s squared plus omega, s squared plus omega squared. That make sense? Okay, so now everything is much better. So we directly write out the time domain signal. That is the inspection method. So we look at this, then we know it. So xt will be equal to, first one, there's a file here, right? So we need to have a file, that's the linear property. we consider this s plus 2 is just the s. So s squared plus omega squared omega. So that is a sine function, right? So that will be a sine what? 3t, right? Sine 3t. Okay, so this gives us 3 over s squared plus 9. But the actual is s plus 2. So we need to deal with this plus 2. So we are going to multiply by e to the power of negative 2t at the front. Then we can write times ut. Right? So that's okay. That's it. Any questions on this? So you can see the trick here is you need to be familiar with the pairs, right? You look at the given Laplace transform, you need to know instantly this looks like a what. Then you need to use mathematical techniques to manipulate this to make it is closer and closer to what we want, and combine with the properties. So any questions on this? Can I give you an exercise? Looks something like in the homework or something. Okay, let's do this. The exercise, xs is, I just put the 15 on the top, there's s on the top. Right? So make this one s squared plus 4s plus 13. And on the top, 15s. Right? Just like that. So you can still use the technique here, right? Definitely you need to use this. So make your procedure easier. Then, but on the top, not 15, it's F15s. You try this for 1 minute, then we do it together. Right? Okay, first one. What does this remind you? Looks like what function is this? Cosine function, right? Okay, that's cosine function. Cosine function, it is on the bottom, that is s squared plus omega. So we know how to do this, right? Perfect square technique. And on the top must be s, right? But remember this one here, this is not s anymore. It is s plus 2. Right? Remember, when we replace this s, we need to, with the s plus a, we need to replace all the s with s plus a. So on the top, you cannot just like 15s. You need to also use s plus a. That makes sense? Okay, let's do this one. E to the negative at sine omega t. Cosine, right? Cosine omega t. What is the Laplace transform for this? We know for cosine omega t, that is s squared plus omega squared. On the top, that will be s, right? But this is e to the negative a multiplied by this. So I need to replace the s with s plus a. So this one here, no longer s, is s plus a, but still squared. This s also needs to be replaced with s plus a. Right? It's not, you cannot just leave like this. So this one must be s plus a. Right? So then when we do that, you need to consider this. Okay? Anyway, done this? Or at least, have you tried? Alright, let's continue on this page here. That's equals Okay, let's do bottom first. S squared plus 4s plus 4 plus 9, right? Procedure for perfect square. I can write directly as s plus 2 squared plus 3 squared. Squared? Right? On the top, it's 15. Right? 15 is here. S, can I just write like this? Do we have s here? We need to have s plus 2, right? Because the s is replaced by s plus 2. Yeah, so we need to write s plus 2. And like a t. Every time you see the s, it is s plus 2. Right? So we cannot write F15s. We need to write F15 because the reason is because we have s plus 2 here. If this one equals plus 3, then you need to write plus 3. No matter what, you need to be consistent. Right? So this one here. Is this good? This one is not equal to this one, right? This one is only 15, but we have 15 plus 2. So we need to minus 30, right? Minus 30, then that will be equal. Make sense? Good? Okay, now can you directly write out the result? We use a linear property, right? So we have second two part. So this one here plus 3 squared on top of 15 s plus 2, and we have a minus 30 on here, and this one squared plus 3 squared. So we separate this into two terms. Right? You don't need to write this one. You can directly see this and this, but for clarity, I write into two terms. This is good, right? All right, now look at this. So xt will be equal to, we consider the first term first. What is it? What function is this?
It's like 15.
That is the cosine function, right? Right, cosine function looks at, again, we consider this one as just s squared. So that will be a cosine what? Omega t. What is omega? This is omega, right? Okay, cosine 3t. That gives us s squared plus 3 on the top. That will be s here. But we have something here, so how to deal with this? That will be e to the power of negative 2t. Yes?
Times 15.
Okay, then times 15. Alright, times 15. Everybody is good with this? Definitely we need to multiply by ut, but we have this term both here, so I leave this to the end. So everybody is good? Okay, now the next term. What function is this? Huh? This one is this one, right? Is this something like this? So that is a same function. So what is it? You look at this, you just copy it. This one is 15, this one is 30. So minus 10 e to the 2t, right? E to the negative 2t and sine 3t.
Where did you get the 10 from?
10. Again, this is 10 times 3. This must be 3.
Oh, okay, I got
right?
you.
Or you can look at this one. This is 15 give us 5.
No, I got you.
15 give us 5. This one, 30 must be 10.
Yeah, that makes sense.
Or you can write this one as 3 times 10. Then make it this one. Question on this? Right? And we have ut here, right? And for all this, but usually we are going to simplify this. So both have e to the ut, right? We both have 5 here, And we are going to write 3 cosine 3t minus 2 sine 3t here times ut like this. Make this more beautiful. Okay, next, if necessary, we can combine these two terms, but you don't need to do this here. Okay, any questions on this? So if I give you a question like this, can you do it by yourself? This one is only example for sine functions, cosine functions. In the table of pairs, there are a lot like this. So you need to be familiar. If you have time, read the tables and get familiar with this. Okay. So this is by inspection. We just only use these two examples to show how to do this. Alright, next one is important part. We are going to discuss inverse Laplace transform with partial fraction expansion. Example 3. Suppose the Laplace transform equals 7s minus 6 s squared minus s minus 6. Right? You just forget what I said, ignore what I just said, the partial fraction expansion method. Can you do this with what we just discussed by inspection method? This is very similar to the example 1 and to the example 2, right? On the bottom we have s squared minus s minus 6, right? And on the top it looks like a s something, so we have sine functions and cosine functions. Make sense? Okay, now let's do this, make this perfect square. Let's see how is it, or what is it. So s squared minus s minus 6 equals, make it the perfect square. S
Equals 3. No, never mind.
half of the coefficient here. So minus half, right? Square. Yeah? Then minus 6. But for this term, we have a quarter in addition, right? To this one. So we need minus a quarter here. Good? Because this one equals s squared here. This is minus s here. We don't have this plus a quarter here. So we need minus this quarter to be equal to this. Yeah? Alright, so this one will be equals s squared, s minus half squared, and minus 6 and a quarter. 6 and a quarter looks like 25 over 4. 25 over 4. So I can write something like this. So this one will be equals something on the top, on the bottom s minus half squared minus 5 over 2 squared. Okay, now what is this? Sine function, cosine function, or something? Yes or no? Cosine, right? No matter sine function, cosine function, this one must be plus. But here we have minus. It looks like a omega squared, but that one is not true. Oh yeah, you can argue. How about I use imaginary? So the frequency equals imaginary. Yes, that is one way to do this. But here we do not use this method. You can consider this one, the frequency is imaginary. That's also good. You can still use that method to come to the same conclusion, so the same result, but we don't use that. If you want to try, you can try after class. But here, looks like, okay, this is there. We cannot use this one. Right? Instead, we are going to use a partial fraction expansion. Partial fraction expansion means we are going to factorize the bottom to make it the whole something divided by something will be equal to some constant over some here, then plus some constant here, then over something here. That's partial fraction expansion. This one is one factor of this one is another factor of here. So that is how we are going to do this. So the next step is we need to factorize f squared minus f minus 6. How to factorize this? Use again, there are a lot of ways to do this, but my favorite is a cross product, right? Say the coefficient here is 1, 1, right? So we have only 1, 1, so no options, only 1 and 1. Okay, negative 6, we have several options. You can use negative 6, 1. This 2 multiplied by equals negative 6. But the cross product, this one equals 1, this one equals negative 6. Add up together, not equal to negative 1. So this one is not going to work. Negative 6. Or if you write negative 6 here, it's still not going to work. Okay? So we forget this. The next one is 2 and negative 3 here. Right? 2 times negative 3 equals negative 6. Right? So the cross product, this one times this equals 2, this one times this equals negative 3. Add up together, right, equals negative 1. So this is good. Right? So this is one way. Another way you want to try is 1, 1, okay, negative 3. Okay, that's the same thing. Others is 1, 1, negative 2 plus 3. That also works, right? Negative 2, 3 equals negative 6. But the cross product, this one is 3, this one is a negative 2. Add up together equals positive 1, not equals negative 1. So this is not going to work. So that's only we have. Right? So the solution will be f plus 2 and f minus 3. Right? So this one will be equals f plus 2 and f minus 3. Any questions on this? If you have difficult doing this, practice more after the class. This part is not the topic in this class. So you should know this before. Any question on this? Okay, now we have two factors. So one factor is here. So I can write this one: 7s minus 6 over s plus 2 times s minus 3, like this. Right? Put this further. Then we have s plus 2 here, s minus 3 on here. So we're going to decompose this into two terms. Here. The next step is to determine constant A and constant B. Again, there are lots of ways to do this. If you look online, YouTube or anywhere, there are lots of ways. Again, my favorite way is when we calculate A, we want to calculate this A will be equal to the original XS. I'll put it right here. Then we are looking for A, right? So I will multiply by f plus 2. So f plus 2 multiplied to this. Then I let f equals let f plus 2 equal to 0. Or this means f equals negative 2. And this is the solution to this one. F plus 2 equals 0, so f equals negative 2. So I just make f equals negative 2. Right, so that is the rule, how to calculate A. Right, let's see what is it. This one, which is this, right? Is this one, but we write in this term. So multiply by f plus 2, so this one is gone. So that will be equals 7f minus 6 over f minus 3. But f equals negative 2 here. So what is it? we plug s equals negative 2 into here. So this one will be equals on the top. What is on the top? Negative 20. Right? What is on the bottom?
Hold on. You got rid of, I see you got rid of s plus 2.
Yeah, because okay, this one is s plus 2 here.
Doesn't doesn't the excess also have s plus 2 in it as well, that you have to take into consideration?
This xs is this, but we write in this term, right?
Yeah.
So equals 7s minus 6 over this over s minus 3 and s plus 2 here, right?
Okay, so
that is a capital X.
So when
But we multiply by this one, right?
yeah, so when
So we're going to cancel these two, right?
never mind. Gotcha.
So the beauty is this part is gone. So you don't need to consider, because we calculate this one, so this one is gone. We don't need this. Right? So that's why it is gone. So always like this, okay? You can see calculate B, same thing, this term will be gone. Now we have this one, then we plug s equals negative 2. This one. And on the top, that is negative 20. On the bottom,
That's
s minus 3.
-5.
Negative 5, so that one equals positive 4. So I just directly write this is 4 here. Alright, so that means here A equals 4, s plus 2. Then I plus this term, s minus 3, B. I need to determine what B is. B, we use the same procedure. B equals, still this one, but we need to multiply. We are looking for B, right? Here, look at this. We are looking for B. So we are going to multiply by this factor. So s minus 3. Okay. And again, make this s minus 3 equal to 0, which means s equals 3. Okay, so in that case, this one will be equal to xs equals this part. Then you multiply by s minus 3, so this term will be gone. So it's 7s minus 6 on the top and s plus 2 on the bottom. We have only these two terms left. And s equals 3. So what is this? On the top, that is 21 minus 6, which is 15.
Yeah.
On the bottom is 3 plus 2 equals 5. So 15 over 5 equals 3. Right? So that's 3. That means B here equals 3. So, okay, so now this one equals 3. In the homework, you need to show the steps, how you get this. I know you have a lot of online tools automatically get this, but we need practice to know how to get this. Okay, so you cannot only give me the result, you need to give me the steps. Alright, I will remove this. Alright. Once we get this one, can we directly write out the result with by inspection? Alright, so what is the first term? We have two terms, right? We got two terms add up together. What's the first one? This look like a...
It's going to be an exponential whenever s must be.
Yes, 1 over s, right? What is 1 over s? That is
This is the
u, right? Unit step. And s plus 2, so that's the exponential. So that will be equals to 4. And e to the negative 2t times ut. What's the second one?
3e to the 3t.
Okay, plus 3e to the positive 3t. Okay, 3t.
All times.
and all together with the ut here. Alright, that's it. Any questions on this? Looks good, right? Alright. Let's do the next one. Example 4. xf equals f plus 1 over f squared f minus 1. Can you do this by yourself? Use the partial fraction expansion. First one, we need to factorize the bottom. What is it? What's on the bottom? S factorize. S times S times S minus 1, right? So that means we are going to write this one as S and S and S minus 1. We have 3 terms. Right? We have A on the top, we have B on the bottom, we have C on the okay. It's good? Look at the first term and the second term. Both have S on the bottom. A is constant, B is constant. Do we need to write it into 2 terms? We can just combine together, right? Yeah, so we can just write, okay, so now that's why it's good, right? Because for example, if you said A equals 1, B equals 2, then add up together equals 3. So this A just equals 3. So no big deal, this one, right? So we can just write this one. Then I will write this term here as B. So this one. Right, now let's do it. What is A? The formula is, this one is S here, right? So I'm going to use S here, multiply by capital X this, and make S equals what? 0, yes, because we want to make this S equal to 0. So S equals 0. Okay, let's see what is this. This one is this. You multiply by S, what we have is S on the top, S here, S minus 1 on the bottom, so S equal to 0. What is this? This one equals 1, this one equals negative 1, this one equals 0 here.
0.
So 1 over 0. Oh, we have trouble here. We cannot do this. Because this one equals infinite. No? We are done. We cannot do this. Okay. You are right. We cannot do this by this method. What's the reason? Looks like we are good at the first one, while this one does not work. Okay. The reason is this S. Look at here. What's the problem? The problem is S here, right? If this one is not here, then everything is good. But this one here, you make this one equal 0, then it won't work. Why? There's S here. Because we only multiply by 1 S here, but there are 2 S's here. So we still have 1 left. So that is the problem. Right? The reason is this one is a multiple root. It's not a unique. So this one actually is a S, there's a double root. So S, because recall, if there's a polynomial x, something like, for example, like S times squared S minus 1. This is the 3rd order polynomial, right? How many roots do we have here? On theory, we need to have 3 roots. But what we have here is only 2. One is S, 0, the other one is 1. But actually, this 0 is double root. That means the first one is 0, the second one still equals to 0, then the next one equals 1. So for this kind of problem, we cannot use this method. This method is not working. Right? So this is called repeated real root. For this one, we cannot do that. Instead, we are going to use FA here. That looks like familiar, right? Okay, now this part is S squared B here. We need to put S squared. You cannot put S here. And then the next term is that is okay. Right? Just put the S minus, put C. So you can see the difference here. Not S here, it's S squared. Right? We need to do it like this. Right? I make this compact. This one equals A over S plus B over S squared plus C over S minus 1. This is a single root, unique. This one is repeated. So how to do this? Okay, we use the same method as before. So first one, we calculate C. C equals S minus 1, right? Times XS here. Then make S equals equals 1. Because we want to make S minus 1 equal to 0. This one here, look at this. On the top, this part will be gone, right? Cancel with this. And we have only this part left and make S equals 1. So what is it? 2. 2, right?
Yeah.
Right, so that's it. C equals 2. Right? So I write this one here because S A plus S squared B plus S minus 1, that equals 2 here. Okay, now the next one, we cannot calculate this, right? We already done this, it's not working. It's equals infinity, but we need to do this. So the second step is we do B. B will be equal to, can we use this, the old method? Okay, yes. S squared times capital X, then make X equals, make X equals what? 0. So then what is this? This one is here, multiplied by S squared, so S squared is gone. So we have only these two terms, and make S equals 0. So what is it? So let me write it first. Okay, so that one will be S plus 1, S minus 1, S equal to 0. So that one equals negative 1. Alright, so B is good. Now B is negative 1. Finally, we still need to calculate A. But this method is not working, right? We cannot use this method. Instead, the method is we are going to take differentiation. Right? Differentiation of this one. So it will differentiation with respect to S of S squared times this, then make S equal to 0. This one here, S squared times XS, is this one, right? That is this. So I just take the differentiation with respect to S of this thing. You still know how to calculate the differentiation, right? Can you try by yourself first? You just calculate what is A is, right? This differentiation when you evaluate when S equal to 0. Everybody try this. It's good? This one, okay, I can write here, right? Still in the camera, okay? ds s plus 1, s minus 1, this one will be equals the bottom squared, right? S minus 1 squared, the differentiation of the top times this one. So this differentiation is 1, then so that is S minus 1. Then minus this one, S plus 1 here, then times differentiation with this, which equals 1. So that's it. Right? So that one will be equals S minus 1 squared on the top of S minus 1 minus S minus 1, so it equals negative 2. Yeah? Right. Then we let S equal to 0. So what is the result? 0, negative 1, 1. So negative 2, right? Did you get it?
Let's go to.
Right? So it must be negative 2. So this is negative 1 here. Alright, so this A will be negative 2. Again, in the homework you need to give me all these steps. Right? I remove this. Now what is xt? This one is negative 2 ut. Right? Negative 2 ut because every term has ut, so I just negative 2 here first, and because I want to come all together. Right? Let's look at this term. What's this term? Right? What is this?
It's the e to the.
That is e to the
Exponential of the e to the negative 2.
e 2 e to the t or to the negative t? To the t, right? Because minus 1, so to the t. So that is this term. And this term, minus 1 over s squared, rt, okay? RT again, because multiply ut to the right, so I just write t, right? RT just t. and this first term is minus 2, right? Then everything together times ut. That's it. Any questions on this? Are you confident that you can do that by yourself? Give you a similar question? Huh? No? Okay, now still need some time to think about it. You need to say yes. Otherwise, now look at this. Ask me a question. What's the problem? So are you good on doing this? Right? If we have a repeated real root like this, sometimes we have a non-repeated like this. So that's easy. We already know how to do this. So you do this first. Use the Euro way to do this. So we determine that C here. That is not big deal. Right? We can easily do this. Now the next one, that is the key. Which one you want to do first? You want to calculate the A or you want to calculate the B? The rule is we calculate the B first. Why you choose B? Because this one is S squared is the highest order. So we calculate the B first. Once we find the B, then we calculate the A, then we calculate all others. Right? Now let's get another example. 5 xs equals s plus 1, s cubed, s minus 1. How are we going to do this? This one equals what?
Look at factor.
Okay, factorize the bottom. How many terms do we have? How many terms? Totally. 4? Okay, we have 4 terms. The first one, the easiest one is s minus 1, right? Okay, so that's A here. That is a unique root, it's not repeated. Then we have s cubed. So we need to start from s, b, then c, s squared. And we still have another term d, s cubed. So now we have 4 terms. Reason is this is a polynomial of order 4, degree 4, okay, as the fourth, so we need to have 4 terms. How to evaluate the ABCD? Which one you want to do first? A, okay, that's easy, right? So A, just use this method. So A is trivial, so we done that. Then what's next? B, C, D. Which one you want to do next? That is important. If you do wrong, then you cannot do it. Huh? D, right? We do this one first. So we multiply by s cubed to this one. So this s cubed will be gone here. right? Then we have only this term and this term left. Then we let s equal to 0. Then we get d. So that will be s plus 1, s minus 1. This term left. This is xs times s to the third. So we get this one. And let s equal to 0. Then we get d. Once we get d, what's the next one? We want to calculate b or calculate c? Okay, we calculate the C. Yes, we go high order in this order, from high to low. This one, we are going to do this. How to do this? Take differentiation of this with respect to s and let s equal to 0 again. Right? So then we calculate the C here. How about the B? Right? The B is we need to calculate the second order differentiation. Right? Do this second order, and we are going to have this one is 2 minus 1 factorial here, and there's 1 here. Right? We have a formula in the slide how to calculate this all these coefficients for higher order coefficient. And you can try by yourself of this one. In this case, this one is 2, then this one will be 2 minus 1 factorial, divide by this, then you differentiation. By this way, we can calculate all the coefficients for repeated root. Questions? So keep in mind, the key here is we calculate the coefficient for the highest order. Then we go step by step, one by one, from the highest order to the lowest order. Right? We cannot do the other direction because we cannot do that. If you try, you'll get infinity. Okay, that is example for repeated root. We have another example here, 6. Xs equals 2s squared plus 5 over s plus 1 times s plus 2. Right? Now I'll let you try this. First line, you determine, do we have a repeated root? Yes or no? Do we have a repeated root?
Yes. You're talking about the top of the
The root means a denominator on the bottom. No, right? This one equals -1, this one equals -2. So we have two different, distinct roots. So it looks like we don't need to go through that trouble differentiation thing, right? That's easy. All right, so what do we do? Equals this, equals s plus 1 here. What is on the top? A. What is here? S plus 2, B. Okay, now you calculate this. What is A? Haven't started yet. Follow the lecture. Oh, hello. Next time you don't need to be here. It's fine.
No, it's just a question.
Anyone get A? What is A?
That is
7. What is B?
13, negative 13.
Negative 13. Alright, before you go next, can you doubt? What?
As you
At least we have 2 get a negative 13. Right? James gets negative 13. And Luke gets negative 13. Did you get negative 13? No? Not yet? Alright, before you go next, can you double check if your 7 and negative 13 correct? I mean, when I say double check, do not just look at what you did. You put the 7 on the for the A, negative 13 for the B, then you do this. Can you make sure that 2 factors, 2 parts add up together is equal to XF? Yeah, so this is good, right?
That's what I'm saying, I wrote that down when you said that.
Okay. So A equals this part multiplied by F, so that is 2F plus 5 or F plus 2, right? This one is gone, cancel with F plus 1, right? Okay, then we make F equals negative 1, right? Okay, so this one here equals 2F plus 5 equals 3 over 1. Is A equals 7?
That's what I got.
Huh?
I got, yeah, I got 8.
I got 3.
Be careful, try again. Let me see, 2s,
Sure.
2f squared. That's 2f squared, not 2s.
I thought that was the one.
Yeah, 2f squared. So 2f squared. So that is 2 plus 5 equals 7. 7 equals 2, that is equals. Right?
Yeah.
So you do a,
Just the final answer.
no, yeah, I said you don't do this first. Once you get this one, right? Can you double check these 2 add up together equals this,
Okay.
right? I believe your 7 and negative 13 is correct, but when you add these 2 terms, is this one equal to this? They must be equal, right?
Yeah.
Can you check? Are they equal? Alright, let's do it together. You already know this one equals, the first one equals 7, right? So 7 s plus 1 plus negative 13 s plus 2. You get this. I believe your calculation is correct, right? Okay, let's see. This one must be equal to this, right? Because equal, everything here. Right? Now let's see. This one will be equal to s plus 1 and s plus 2. I just go reverse, add these two terms to check if this equals this. Right? This one equals this, so this is 7 and s plus 2, then minus 13 s plus 1 here, right? Right, so that one will be equal to s plus 1 on the bottom, s plus 2 on the bottom. That is good. Now let's see what is on the top. 7s minus 13s, so negative 6s. 14 minus 13 equals 1. That is what you get. Not equal to this one. And I believe your calculation is correct. And our calculation here is also correct. But this one is not equal to this. So what's the problem? You use this method, calculate this, every step is correct, and the result is wrong. What is the problem? The method is wrong. Right? You use this method, you did everything correct, but the result is wrong. What's the problem? The problem is the method is wrong. That means we cannot use this method to do this. Why? What's the difference between this and this what we discussed before? Looks no different, right? Okay, yes, there is difference. Look at here, right? Negative 6s plus 1, right? S plus 1 here, s plus 2 here. Looks this is good, because if we go this way, this one is good. But this one is not. What's the difference between this and this? On the bottom, the degree is 2, right? S squared. On top, this one is only the first order. Degree is equals 1. There's no s squared term, but we have s squared term here. Right? So this kind of polynomial is called improper. Improper. Because the degree on the top is greater or equal to the bottom. This one is proper. Because the degree on the top is 1, the degree on the bottom equals 2. So that's less than. So this is good. This one is not that good. It's improper. So for improper polynomials like this, we cannot use this method to do this. Okay? Instead, we need to do long division first. Then use this method. Right? To make this one proper. Right? So here is the key. We are going to do long division first. Right? So 2s squared first. Right? 2s squared plus 5 divided by s plus 1 times s plus 2. For long division, we need to do polynomial by polynomial. Cannot do factors. So we need to use this one as s squared plus 3s plus 2. That is s plus 1, s plus 2 multiplied together equals s squared plus 3s plus 2. Right? Make sense? Everybody? Good, what we get here, right? That is s plus 1 times s plus 2. Okay. So this is s squared, this is s squared. So what is the quotient? We only compare the first term, the highest term. So 2s squared, s squared, divide equals 2, right? Okay, so we are going to put 2 on the top here. That's the constant. Right? Okay, now I will need to multiply. This is the division, right? So this one times this, put here, then subtract, right? So s times this one is 2s squared plus 6s here, then plus 4 here, right? Then we subtract. This part is gone. This one is negative 6s, then this equals 1. Alright, so that this divided by this will be equals to 2 plus this, remainder equals this. Right? Then this part will be equal to, I will write 2 here, and the remainder is here, so that will be on the top, and the bottom is still the same. For example, 15 divided by 7. What is this? 15 divided by 7 equals 2, 14, and remainder equals 1, right? We are going to write 15 divided by 7 equals 2 here, and the remainder is on top, and the 7 is still here. Right? So that is 2 plus this one. So that's why we have 2 here plus this or this. Question on that? So this, we make this improper polynomial into a proper. Right? So this one here is good, then this one is proper, right? This one is a remainder, so the degree must be lower than this one. Then what's next? Right? The next one is easier. So we just do this. Right? So this one will be equals to 2 plus this, because 2 already here. Now we determine A and B by the method. Right? So the result, right? You already know how to do this. Keep in mind this part here only worked for this one. We do not need to care about this part anymore, right? Because this 2 is already here. So we only work on this part, you do this, to decompose A and B. Right? So this result equals 2 plus S plus 1, and 7 minus 13, S plus 2. Look at this. What's your result? Still correct. 7 and negative 13. But what you missed before is this constant 2 here. That is the part that we need to correct. The method we used before is wrong, but our result is correct. 7 is still here, negative 13 is still here. But we need to have a constant 2 here. Okay, now can you tell me what's the result? You can still use this part, use yours as this one, right? Still this one is good, but you need to add this term. What is this? This is e to the negative t times 7. This one is e to the negative 2t times negative 13. You already get this. What is this? The inverse Laplace transform of 2. Recall the pairs.
2 impulse.
2 impulse. The first one, the impulse is 1. So this one gives us a 2 impulse. So 2, this one. So we forget this part.
The next one is just e to the...
This one plus 7 e to the negative t minus 13 e to the negative 2t. And you multiply by ut here, or here, doesn't matter, but just like this. Questions on that? Okay, so now let's see. So if I give you a Laplace transform, ask you to calculate the inverse Laplace transform, what I'm going to do is first step, come by and think about all these examples. The first one you need to check.
See what the powers are.
If it is improper or not, right? If the power, for example, here is higher or equal to, you need to do long division first to simplify. We have some, for example, if this one equals s cubed, here we are going to have s term on the front, right? So you reduce the degree of the top to make it proper. Right? So that's the first step. If we already done this, so make the polynomial proper, what's the next line you need to check? You need to consider if the roots are repeated or not. Right? If they are repeated, then you need to use the procedure for the repeated root. If not, then you will be happy. If not, then just very simple. Questions? So I'll give you a Laplace transform. Can you do the inverse Laplace transform? Yes or not quite sure? Percentage? 80%?
80%, 75%,
75%?
70%,
70%?
65%.
65?
A passing grade.
A passing grade.
I think I got 70% of it, yeah.
So what's the problem? What's the other 35%?
The long division.
The long division. Okay, so
No, just.
Huh?
Real mistakes.
I know. I got 100.
Okay, long division. I'll give you an example to do the long division. Alright. The long division, you need to arrange the polynomial in decreasing order.
Yeah.
Alright. So for example, I make this one real S3. Alright. We just use this example. That's good. You give me the question, and then we solve it. Then you make this 30% gone. Alright. So you get 100%. So look like this one. If the top, for example, equals 2 cubed plus 5, like this one, make this. Then you divide it by, this one is not in the polynomial, traditional, general polynomial. We need to make, this is a factorized form. We need to make the polynomial. So s squared plus 3s plus 2. Right? So now, usually you are going to make this one have some space. Otherwise, you are going to mess up. So I have here, so there's an s squared here, there's an s here, there's a 5 here. I make this one. Right? When you write this one, you need to consider this. S cubed, s squared, s, then constant. Divide by this, you only consider the first term. Right? The first term of this one is 2s cubed, this is s squared. You use this one divided by this. What is the result? 2s. Okay, 2s, where to write the 2s? This one is s squared, this one is s, right? Okay, we write 2s here. Hello? Hello? You know how to do this, right? Are you sure? Okay, so that's 2s is here. Then this one multiplied by all this one. So that is 2s cubed. Then s, 2s, 3s, that is plus 6s squared. Then plus 4s here. Because a line is not subtract. This part must be gone because this one is from here. So this one is gone, right? So this one will be negative 6s squared plus minus 4s plus 5. That's good? Okay, now look at this one. On the bottom, this is s squared, right? But we still have s squared. That means we haven't finished yet. We reduce the order on the top from 3 to 2, but 2 is still not good. We still need to do this. So now negative 6s squared, this is s squared. What's the quotient? Minus 6, right? Right. So minus 6 over this one, so minus 6s squared. This one is minus 18s. This one is minus 12. Good? Okay, now subtract. This one must be gone. If not, it means this number is incorrect. Right, so this one is gone, and this one will be 14s. This one will be 17. So good? Now, this is constant. That means we cannot do this anymore. This one must be good. So this is s, and on the bottom that's s squared. So that is proper. So what we have here is we are going to write this as 2s cubed plus 5 over s plus 1 s plus 2 this one will be equal to 2s minus 6, that is the quotient here. Then plus everything on the bottom we copy, s plus 2 here, and the remainder will be on the top. So 14s plus 17. Alright? So
Just do the inverse Laplace of the 2s.
only for this part.
Only for that part.
Yeah, because this one you just put here, this one is good. So we already simplified. So you just copy 2s minus 6, then you need to write this one as in the, because they are unique root and proper. So we just write s plus 1 a plus s plus 2 and b. You only consider this part. So far you forget this, but you pick this up at the very last step. Make sense, everybody? Right. So now, for example, how to calculate A? A will be, forget this, all right? Don't go back to the original. That is, you may make this mistake. Don't go back to here. You only use this part. So this one multiplied by s, so that is 14s plus 17 over s plus 2, right? This part multiplied by s plus 1, so cancel this, so we have only this left. Then make s equals negative 1, then you evaluate, that is A. And B is the same thing. Again, forget this, right? We use this part. So that will be 14s plus 17 over for B, we need multiply by s plus 2. So that means s plus 2 is gone, so we have only s plus 1 here. Then make s equals negative 2, right? Then you evaluate, you get something. Then you put A here, B here, so that's all. And for this 2s, what is this? It's looking like the impulse differentiation. So that is, we didn't discuss the real signal. So it's, right? But this one is an impulse, right? We already know that this constant is impulse. And this one will be e to the negative t times A. This one will be e to the negative 2t times b. So everything is clear. Question on that? Now, what's the percentage? 80, 90? Okay.
82.
82. Alright. We still have the last slide to discuss how we are going to use this method. We are going to use this one to solve differential equations. For EET student, you need to take differential equations. That is your last chapter. You're going to use this one, so you're going to benefit from our class here. Who is taking D right now? Several? All three? Okay, good. At the end of the semester, I believe you're going to use the Laplace transform to solve differential equations. We don't discuss too many details. I only directly give you one example. D, and we want to solve this dy squared t dt squared plus 6 dyt and dt plus 8 of y output, right? And this one equals 2ut, and the initial conditions are when t equals 0, the output equals 1, and the differentiation when t equals 0 and equals negative 2. Right? We want to solve what y is. For circuit analysis, this one may be ILC circuit, LC circuit, LC circuit, second order circuit. What we do is we take the Laplace transform on both sides. We assume solve solution. Assume yt, it is Laplace transform is ys. Then what is yt differentiation? Again, the properties. Differentiation of this if yt gives us ys, what is differentiation give us? That gives us s times ys, then minus the initial condition of y0. y0 equals 1. So in this case, give us this one. It's good? You need to memorize the properties, all right? Then, how about the second order differentiation? What does this give us? This gives us s squared ys minus s times the y0 which is here times 1, then minus this first order differentiation, so equals minus 2, minus 2, so equals plus 2. Right? So we don't need to write this one here. Okay, now almost gone, right? Almost done. This one, take the Laplace transform on both sides. This one, Laplace transform equals this. So what you have is s, y, s. I don't write y, f anymore. You know y is a function of f. Right? Y minus s plus 2. So that is for this one. We get this. Right? Then the second term, this one here will be plus 6. dy dt give us sy minus 1. So this term here give us this term. Right? Then Laplace transform this. 8yt give us 8y. Yt give us 1. Right? So now right hand side 2ut. What is 2ut? Laplace transform? Ut is
Whatever s, so it's me.
okay, so just 2 over s. Right? Right? That's easy. This is a differential equation. Now we need to solve ys. This one is a algebraic equation. Right? Can be easily solved. So this one will be equals s squared plus 4s plus 2 over s squared plus 6s plus 8. You manipulate this, you get ys equals this. The next step is to try to find the inverse Laplace transform. Right? First one, step 1. Is this proper? Means the degree on the top is lower than the bottom. Is this proper? The degree on the top equals 2, right? The degree on the bottom is 3. Is this proper?
Yeah.
Yes. Oh, okay. So we don't need to do the long division, right? Next one is okay. We need to factorize this. So this one equals so this one on the top s squared plus 4s plus 2. This s here. This one is what? Right? You use a cross product. This one s plus 2, then s plus 4. Right? Look at this. Do we have a repeated root? Huh? Yes or no? This root equals 0, this one equals negative 2, this one equals negative 4. Do we have a repeated root? No. Okay, now good. We can just use the simple method to do this. So this one will be equals what is it? S here, A plus S plus 2 here, B plus S plus 4 here, C. So all the complicated part is gone, and this question is very simple, so we get this one. So can you calculate A? Can you calculate the B? Can you calculate the C? Right? So the A equals a quarter, and B equals a half, and C equals a quarter. So the next step is the inverse Laplace transform. What does this term give us? Then the xt equals, what's the first term? A quarter ut, right? Just one. Okay, good. What's the second? This one is half e to the negative 2t. What's this? A quarter e to the negative 40. Then all this together with the ut. That's it. That is the Laplace. This is the sorry, not x. It's y because we are looking for yt. So that's the solution of the differential equation. We use the Laplace transform first, then we get the y, then we calculate the inverse Laplace transform. Okay. Any further questions? Okay, that's it. Thank you.